Happy New Year, and today I want to show you a special fact about the number 2021 that mathematicians don't want you to know about. Because even though it is true that 2021 is the product of two prime numbers, 43 times 47, there's actually much more to that than this. In fact, today I want to show you the following. There is only one group of order 2021. And again, it has to do with the special structure of that number because, for instance, 6 is the product of two prime numbers, yet there are many groups of order 6. So, what makes this number so special? Watch this video to find out. So, let G be an arbitrary group of order 2021. Well, first of all, we do want to use the fact that it's a product of prime numbers and see what that tells us. Well, 2021, it is 47 times 43, and because 47 is a prime number, we can use something called Cauchy's theorem or Syloh's theorem that to guarantee us the following. Namely, there is some element in the group whose order is 47. So x to the 47th power becomes the identity element of the group. And of course, naturally then, it is natural to consider the subgroup generated by x. And let's call that h. So let h be, think of it as the span of x, and it's just e x, x squared, x cubed up to x to the 46. Because then x to the 47 brings us back to e. And we have this nice cycle of length 47. And I will talk about this later, but notice this will be basically isomorphic to z to the 47, if you know what this is. And well, since 43 is also prime, we can play the same speed and we obtain the following. There must be some other element in G with order 43. And then you can just consider the subgroup generated by that element, which is just y squared up to y to the 42. How cool that there's a 42 appearing here, by the way. And again, this is because those two numbers are prime. And what is G equal to? Well, let's look at the next step. So what do we know? We have this mystery group G and the two subgroups H and K. And it turns out H and K, they're not ordinary subgroups. They're very special ones. And in fact, let me show that H is a normal subgroup. So H is a very special subgroup of G. And for this, again, we want to use the fact that 2021 is the product of two prime numbers, but now the special structure will appear very soon, I promise. Because what do we know? Well, G, that is 2021, and that's 47 times 43, but 47, that's precisely the order of H, and 43 is a prime number. Because of this, H is what's called a 47 Syloh subgroup of G. So H is a 47. I know it looks like a, you name a robot that, 47 Syloh subgroup of G. And in fact, and this is the key to our proof, let's figure out how many such subgroups there are. So let nk, or not nk, n to the 47 be the number of such subgroups. So 47 Syloh subgroups. Then it turns out the number of such subgroups satisfies a very special identity, which is the following one. Then we know the following. The number of such subgroups divides the other prime number, 43, and also that number is always congruent to 1 modulo itself. And, well, which positive numbers divide 43? 1 and 43, but 43 doesn't satisfy the second one, and so in the end, we get that n to the 47 has to be 1. So in other words, this subgroup H is very special. It is a 47 CELO subgroup, but there's just one of them. So there's a unique such subgroup, which is H. And why is that important? Because remember, all those CELO subgroups, they're conjugate to each other. And so now let's do actually the proof that H is normal. So let G in G be arbitrary, and consider the following. G, H, G inverse. Look, remember what I told you. The CELO subgroups, the CELO 47 subgroups, they are conjugate to each other. So this thing, by definition, this is called conjugation, is a CELO 47 subgroup. But remember, there's just one of them, which is H. So automatically we can say that GHG inverse is H. And then multiplying by G on the right-hand side, we eventually get that GH is HG. And this precisely means that H is normal in G. Ta-da! So this subgroup H is very special. So let's keep, it's our precious, let's handle it with care. And it turns out the beautiful thing is, the same thing is true with K. So here are the details if you want to know. So similarly, K is a CELO 43 subgroup, since 2021 is the order of K times a prime number. And then what do we know of the number of such subgroups? Well, it divides the other prime number, and it's congruent to 1 modulo itself. And it turns out the only number that satisfies this is 1. So that subgroup number of subgroups is still unique, and which, as before, implies that K is normal in G. Now, what is it about 2021 that makes this work, and such that it doesn't work for 6, for instance? Because what do we know? Here we found that 2021 is P times Q, because it's 47 times 43, where P, Q are prime numbers, and P is bigger than Q. But again, that's still true for 6. But what makes this work is simply the fact that Q does not divide P minus 1. Because you see, for 6 this wouldn't work, because 6 is 3 times 2, but 2 would divide 3 minus 1. So that's why 2021 is so special. It's the product of 2 prime numbers, but where the smaller one does not divide the bigger one minus 1. And this is ultimately the little innocuous ingredient that makes this work. And in fact, given the fact that we have those 2 normal subgroups, let's see what more we can say. In fact, let's show the following quite surprising fact, namely claim G is just H times K. And what does H times K mean? It's not Hell's Kitchen, but if you take any element of G, it is of the form some element in H times some element in K. So in other words, if you take the product of 2 elements, one in H, one in K, you eventually get, any element in G, which is quite a nice decomposition. But the proof is very simple and quite elegant, I have to say. Because what do we know? On the one hand, this, set of products, it is a subgroup. So HK, think like subsets, but even better. So HK is a subgroup of G. But moreover, it turns out the sizes match. Because, well, what is the size of HK? Well, by some theorem, probably Cauchy's theorem, I don't know. There are many things called Cauchy. That is the size of h times the size of k divided by the size of the intersection. Now, what do we know about this intersection? Well, h intersect k, it's still a subgroup of h and k, so by what's called Lagrange's theorem, it has to divide h, the number of elements in h, which is 47, and it has to divide the number of elements in k, which is 43. So we have this number that divides both 47 and 43, but because those are relatively prime, it has to divide 1. So the only number that divides both of those together is 1. But what do we have? H intersect k is a subgroup of order 1, and we don't even need that, but it means it's trivial. We will need that later, but anyway. So the point is, this denominator becomes 1, and so hk is the number of elements in h times the number of elements in k, which is 47 times 43, and that's 2021. So hk is a subgroup of G with the same number of elements, and since both are finite, we ultimately get that G equals hk. So you see, without any messy computations, we automatically get this beautiful fact, which leads to our next step. Because remember, I still haven't told you what G is. Well, it turns out, interestingly, the crux of the proof lies in showing that G is commutative, or abelian. And in order to show that, we need an intermediate step, which you'll see why it shows our result. So step 4, we want to show the following. Namely, if you take any element in H, and any element, arbitrary element in K, so if H is in H and K is in K, then actually those two things commute. Then HK equals KH. So again, I am not saying that G is abelian just yet. I'm just saying if you take one thing in H and one thing in K, those two things commute. And in fact, you'll see that the proof is absolutely beautiful, because consider the following. So hk times, if you want, hk inverse, so or hk times h inverse k inverse. So kh inverse. So consider the thing, okay? And remember, we haven't used the fact about normal subgroups yet, but this comes precisely here, because on the one hand, it equals to hkh inverse k inverse. But this k is in the big group K. On the other hand, here all you're doing, you're just conjugating k by this element h. But because k is a normal subgroup, all it means is that that conjugation is in k. So this is in k, this is in k. So the product of two things in k is in k. I know. Okay, get it? That's on the one hand. And again, the normal subgroupness was crucial here. On the other hand, well, this thing, it's the same thing as h, k, h inverse, k inverse. Well, now we can play the same spiel, because h inverse is in h, but you're conjugating, and h is normal, so this whole thing is in h. Well, h is in h, and so the product of those two things is in h. So this mystery element is, well, in k, and by equality, it's also in h. So in the end, what do we get? We get that hk, h inverse, k inverse, is in the intersection of the two. So k intersect h, or if you want, h intersect k. But what have I shown in the previous step? By accident, I've shown that h intersect k is just the identity group. So the small subgroup consisting just of the identity element. So what this means is HK H inverse K inverse must be equal to E. H inverse K inverse equals E. Okay. But now, multiplying the right hand side by K, we get that HK H inverse equals K. And then multiplying to the right by H, we get that HK is KH. So Hell's Kitchen is Kel's Hitchen in some sense. So again, this is really neat, and that's again where we needed the crucial fact about normal subgroupness. So this, I believe, would not really work for 6. No. So it's really, we live in a good year, and hopefully we have a lot of good time in this year. All right, but how would that show that G is abelian? Well, now we can finally show this. So let's show that G is abelian. And by the way, I'm so teasing you so much because I still haven't told you what what G is. Remember, I told you there's just one group of order 2021, but it turns out this will be a very crucial step. So in other words, to show G is abelian, suppose A and B are in G, but remember, G is just H times K. So sorry, HK in some sense. So what this tells us is A is HK and B it's H prime K prime, where H prime are in H, K prime are in K. Okay, and now calculate AB. That is HK, H prime K prime. And remember, by the previous step, it's okay to interchange anything with K with anything in H. So this becomes H prime, K prime. Now, in general, it's illegal to interchange anything internally. But now here's where we need the fact that H actually has a concrete definition. It's the subgroup generated by X, and K is the subgroup generated by Y. So all this is telling us is that H and H prime, they're just some powers of X. Let's say X to the M, X to the N, and same thing with K. K is Y, let's say, to the L, and Y to the P. Then what this becomes, that is just X to the M plus N, Y to the L plus P. But it's okay to interchange integers. That's not an issue. So X to the N plus M, Y to the P plus L, and that just becomes X to the N, X to the M, Y to the P, Y to the L. But in terms of our original definitions, that's just H prime, H, and then K prime, K. And now interchanging, H and K prime again, which is, again, totally legit, this becomes H prime K prime times HK. And by definition, this is just BA. So AB is BA, and since A and B are arbitrary, we actually get that G is abelian. And now for our last revelation, I can show you what G is. Okay, so what is G? Well, G is an abelian group of order 2021. In 2021, in terms of prime factors, you can write this as 43 times 47. If you know some algebra, you are done, because what you can do, there's this thing called the fundamental theorem of finite abelian groups, which simply says that G is isomorphic to Z of 47 times Z of 43. And what is Z of 47? It's simply 0, 1, 2 up to 46, but with the understanding that 47 is just the same as 0. So it cycles back and forth, and same thing with 43, Z of 43, that's 0, 1, 2 up to 42, with the understanding that 43 goes back to 0. Since 47 and 43 are relatively prime, then this is the same thing as Z of 47 times 43. So isomorphic, which is the same as Z of 2021. So in the end, what do we get? The only group of order 2021 up to isomorphism is Z of 2021, which is just a set 0, 1, 2, up to 2020. So if you think we're done with 2020, no, it's here. It's still haunting us. Of course, this is assuming you know a lot of algebra, but let me fill in the details. So ta-da, here's the result. So in this step, I will show now this fact, and then I will show this fact in the other step. All right, so here are the details. To show that G is isomorphic to this set, let's find an explicit isomorphism. So define the following isomorphism: phi from H times K to G, and simply defined as follows. So remember, H is the cyclic group, generated by X. So it's X to the M and then Y to the N. And what phi does is just concatenates the both of them. So X to the M, Y to the N. And then what you can show, so this part I will skip, you can show that phi is a homomorphism. And moreover, And then you can show the following. First of all, this is well defined, provided that you choose m between 0 and, I believe, 46, and n between 0 and 42. So that works. So it is well defined. And then you can show it's a homomorphism because of the commutativity property. That's not a big issue. And then the question is, so for isomorphism, you have to do surjective and injective. Surjective is actually quite nice because the question is, why is G of this form? Why is L an element of G of this form? Simply because we have shown, so we've literally shown that G is H times K. So literally any element in G is a product of an element in H times an element in K. And lastly, why is it injective? Because it is surjective and the sizes match. Because what is the size of G? Well, it's 2021. And that is 47 times 43. And that's the size of H times the size of K. And that's the size of H times K. So by one of those theorems, I think Schröder-Bernstein or something, we get that. In fact, it's an isomorphism. So in fact, G is isomorphic to H times K, and of course, just identifying the elements with the exponents, we get that H is isomorphic to this thing, and K is isomorphic to that thing. So that's not an issue. And last but not least, why is this isomorphic to Z of 2021? Well, let's see why. To show the last result, all we need to show is that Z of 47 times Z of 43 is isomorphic to Z of 2021. And for this, simplify, define the following isomorphism, namely psi, let's say goes the other way around, so Z of 2021 to Z of 47 times Z of 43. And simply as follows, so given x, again between 0 and 2020, just take the remainder mod 47 and the remainder mod 43. And then, well, you can show that this is a homomorphism. And then for injective, it's quite interesting. So suppose x mod 47 is 0 and x mod 43 is 0. Then what this says is x is a multiple of 47 and 43. Now, in general, what I say now is not true, but it is true because they're relatively prime. What it is simply that x is a multiple of the product, which is 2021. But then what this says is, at least in Z of 2021, x is 0. Okay. and that shows that the homomorphism is injective. And for surjective, I think it's equally interesting. It involves some number theory, but the point is, suppose, let's say x mod 47 is m, and x mod 43 is n. Can we figure out what x is? Is there an x that satisfies those two congruence relations? And I believe yes by the Chinese remainder theorem, but if you don't know what that is, since 47 and 43 are relatively prime, they're integers, a and b, such that a times 47 plus b times 43 equals 1, and I believe all you need to do, you just need to define x to be a times 47 times n plus b times 43 times m. Let me just double check that. Yes, and you can check that in fact, that at least mod 2021 if you want. And you can check indeed that x mod 47 is m and x mod 43 is n using those identities. And this concludes the proof, I guess, yeah. So again, Happy New Year, and I hope that 2021 brings lots of happiness and algebra, even though they do commute. And if you like this and you want to see more math, please make sure to subscribe to my channel. Thank you very much.